Next topic which we have to study or which we have to understand is value of polynomial. Okay, value of polynomial at given value of variable will be what? Okay, suppose we have a polynomial in variable x, px. Okay, and you are asked to find value of polynomial px at some value of x. Okay, so its value will be given by replacing x. Okay, replacing x from the polynomial and putting the given value of x into that. See, value of polynomial px at x equals to a is pa. A is any constant number or real number. A can be any constant number or real number. Okay, so value of polynomial px at x equals to a will be pa, means in place of x you have to put a. For example, let us take one example to understand. Px, suppose we have a polynomial px in variable x. Okay, and it is x square plus 2x plus 6. See, here we have three terms. First term is x square, second term is plus 2x, third term is 6, which is constant term. Then if you are asked to find the value of polynomial px at x equals to 2, then what you will do? You will put 2 in place of x. Okay, then px at x equals to 2 will be p2. So p2 will be given by, see, in the px we had first term x square, so in place of x we will put 2, it will be 2 square. Second term is 2x, then second term will be 2 into 2. Okay, because in place of x you are putting 2. And third term is constant as it is 6. So 2 square is 4, again 2 into 2 is 4 plus 6. So 4 plus 4 plus 6 is 14. Okay, so value of polynomial px at x equals to 2 is 14. Okay, this will be given, this will be called as, or this will be written as value of polynomial px at x equals to 2 is 14. Okay, now let us understand what are zeros of the polynomial. See, zero of a polynomial px is such a number. Okay, zero of polynomial px will be some value of x at which polynomial will become 0. Okay, this is I am explaining in my words. See, according to the definition, zero of a polynomial px is a number a such that pa will be equal to 0. It means zero of polynomial px will be a number or real number a. A is a real number. Okay, such that at this value of a, polynomial will become 0. If you will put a in place of x in the polynomial, the value of polynomial will become 0. Okay, this was the definition, and in simple words you can say zero of a polynomial is such a value of variable. Zero of a polynomial is such value of variable at which polynomial becomes 0. Okay, so that value of variable will be the zero of polynomial. And zero of polynomial is also called the root of the polynomial. Other name of zero of polynomial is root of the polynomial. Okay, and one more thing, the maximum number of polynomial is equals to its degree. Like you have a polynomial with degree 5. Okay, so it will have 5 zeros. If you have degree of polynomial 3, then it will have 3 zeros. Okay, now let us understand. See, px, we have a polynomial px and its degree is 4. See, its degree is 4, no? So it will have 4 zeros because it has degree 4. Now let us understand how to find zero of a polynomial, linear polynomial. Zero of linear polynomial. Okay, how to find? Py is equals to, see, we have a polynomial in variable y which is 3y minus 2. Okay, then we have to find its 0. What we'll do? We'll equate this polynomial to 0 to get the value of y. See, you are here, you are finding 0 of a polynomial. Okay, linear polynomial. 0 of a polynomial you are finding. Then to find 0 of a polynomial, you need to equate this with 0. You need to equate the polynomial with 0. Then 3y minus 2 equal to 0. After transposing, it will be 3y equals to plus 2. Then y is equals to 2 by 3. 2 by 3. Here I have written 3 by 2, it is 2 by 3. So y is equals to 2 by 3 is the 0 of a polynomial. Why it is a 0 of a polynomial? Because if you put here y equal to 2 by 3 in this polynomial, then 2 by 3, okay, 3 into 2 by 3, 3 cancelled out, they will get it will get divided, and remaining will be plus 2 and minus 2, 0. The polynomial becomes 0 at y equals to 2 by 3. Okay, so y is equals to 2 by 3 is the 0 of the polynomial. Let us start exercise 2.2. See, first question of exercise 2.2 is find the value of polynomial 5x minus 4x square plus 3. This is the polynomial, okay, at x equals to 0, at x equals to 2, and some more values are given. Okay, we have to find the value of this polynomial at given value of x. Okay, means value of polynomial at given particular value of x. See, x equals to 0 you have to put in this. Okay, px is this 5x minus 4x square plus 3. At x equals to 0, px will be p0. So we have to find value of polynomial at x equal to 0, which is p0. Putting 0 in the place of x is 5 into 0 minus 4 into 0 square plus 3. Okay, this will become 0. This term is also 0 plus 3. So remaining will be 3. Means value of polynomial, value of this polynomial px at x equal to 0 is 3. Okay, polynomial px at x equals to 0 is 3. See the second one. If we put x equals to 2 in this given polynomial, okay, px was 5x minus 4x square plus 3. Okay, at x equals to 2, as it is given in question, at x equals to 2, this px will become p2. p2 means in place of x you have to put 2. So p2 is equals to 5 into 2. 5x was there, no? So 5 into 2 minus 5x square, sorry, 4x square. So 4 minus 4 into 2 square plus 3. 5 into 2 is 10. Now 4 into 2 square means 4 into 4 is 12. Sorry, 2 square is 4, no? 4 into 2 square means 4 into 4 is 16 plus 3. So 10 plus 16 plus 3. 10 plus 16 is minus 6 plus 3 is minus 3. Okay, so value of polynomial, value of this polynomial at x equals to 2 is p2, and p2 is equals to minus 3. Now see question number 2. Question number 2 is find p2, means value of polynomial at variable equals to 0. p1 and p0, p1 and p2 means values of polynomial at given values of variable. Putting variable equal to 0. In this we'll put variable equals to 1. In this we will put variable equals to 2 for each of the following polynomials. Okay, see, we have taken second bit here first. See, we have a polynomial in t, pt. pt is equals to 2 plus t plus 2t square minus t cube. Okay, we have 4 terms here. First term is constant, then t, then 2t square, then minus t cube are variable terms. Okay, see, pt is equals to this p0. p0 is what? p0 is pt at t equal to 0. p0 will be what? Polynomial at t equals to 0, means in the place of t you have to put 0. Okay, so p0 will be 2 plus 0 plus 2 into 0 square minus 0 cube. All these terms will become 0. So value of polynomial at t equals to 0 is 2. p0 is 2. Polynomial at variable equal to 0 is 2. Now p1 you have to find. p1 means in place of t you will put 1. p1 is pt at t equal to 1, means polynomial at t is equals to 1 is p1. So p1 is in place of t you will put 1. Okay, p1 is equals to 2 plus 1 plus 2 into 1 whole square minus 1 cube. Okay, so p1 is equals to 2, this 2 as it is, 1 plus 2 minus 1. Okay, so this plus 1 minus 1 cancelled out, and 2 plus 2 is 4, means value of polynomial is 4 at t is equals to 1. Value of polynomial pt is 4 at t is equals to 1, means p1 is 4. Also we have to find p2 also, means value of polynomial at t is equals to 2. Okay, p2 is pt at t equals to 2. Polynomial pt at t equals to 2 is p2. In place of t you have to put 2. So p2 is equals to 2 plus 2, it was t, so in place of t we will put 2t square. So 2 into 2 square minus 2 cube, because here it was t cube, no? So 2 as it is, here 2 into 2 square, 2 square is 4, into 2 is 8, and 2 cube is 8, so minus 8. So minus 8 plus 8 cancelled out, and 2 plus 2 is 4, means again value of polynomial at t is equals to 2, which is p2, is 4. Now see the second bit is px. Second bit is px equals to x minus 1 and x plus 1, and we have studied the identities in standard 7th that if we have two numbers, or you can say two real numbers, or two variables, okay, as a plus b multiply a minus b, okay, a plus b multiply a minus b, then it will be given by a square minus b square. So here if we consider x as a and b and 1 as b, so we have here a minus b multiply a plus b, okay, which will give us x square minus 1 square. Okay, so polynomial x minus 1 into x plus 1 can be written as x square minus 1. This is the polynomial. Okay, then we have to find the value of this polynomial at 0, at 1 and at 2. Okay, so p0 is what? It is px at x equals to 0, means in place of x you will put 0, then it will be p0. So p0 is equals to 0 square minus 1. Okay, x square minus 1 means 0 square minus 1. So p0 is minus 1, means value of polynomial at x equals to 0 is minus 1. Now p1 is px at x equals to 1. p1 is px at x equals to 1. Okay, so which is p1 equals to 1 square minus 1. Value of polynomial px at x equals to 1 is 0. Okay, means in place of x in the given polynomial, this is the polynomial, in place of x you will put x equals to 1, so it will be p1. So p1 is equals to 1 square minus 1, so 1 minus 1 is 0. Here we got value of polynomial 0. Okay, so let us recall the zeros of the polynomial. If value of polynomial is 0 at some value of variable, then it is called a 0 of a polynomial. Means what? X equals to 1 will be the 0 of a polynomial, because this polynomial is becoming 0 at x equals to 1, or putting x equals to 1, this polynomial is becoming 0. So x equals to 1 is the 0 of the polynomial. Now p2 means value of polynomial at x equals to 2. Okay, so p2 is x square minus 2, means 2 square minus 1 is 3. Polynomial is 3 at, value of polynomial is 3 at x equals to 2. See question number 3. Verify whether the following are zeros of the polynomial indicated against them. Okay, see the first one, we have to check whether x equals to minus 1 upon 3 is 0 of this polynomial or not. Again recall the definition of the polynomial, 0 of a polynomial. A given value of variable will be 0 of a polynomial if and only if it makes the value of polynomial 0 by putting in the place of variable. Means if you put x equals to minus 1 upon 3 in this polynomial and the value of polynomial turns out to be 0, then this x equals to 1 upon 3 will be called as 0 of the polynomial. So check it, let us check it. Px is 3x plus 1 at x equals to 1 minus 1 upon 3. Px will be p minus 1 upon 3, means you have to put x equals to minus 1 upon 3 in this px. So it will be p minus 1 upon 3. Okay, now p minus 1 upon 3 is equals to 3 into minus 1 upon 3 plus 1. So this 3 and 3 cancelled out. 3 ones are 3, 3 ones are 3. Okay, now remaining is minus 1 and plus 1. Minus 1 plus 1 is 0. Again this will be cancelled out. So polynomial at x equals to minus 1 upon 3 is what? 0. Okay, this polynomial or this value of polynomial is turning out to be 0 at x equals to minus 1 upon 3. It means what? It means what? X equals to minus 1 upon 3 is the 0 of the polynomial. Now let us solve this fourth bit of the same exercise. See, px is equals to x plus 1 into x minus 2. Here this is not the case of a plus b and a minus b, okay, because a is same here but b is not same. This is some other number and this is some other number. Okay, so we will solve it by distributive multiplication. See, x multiply x, then x multiply minus 2, then 1 multiply x, then 1 multiply minus 2. Okay, so x multiply x is x square, x multiply minus 2 is minus 2x, then we'll multiply the second term over this. So 1 multiply x is x and 1 multiply minus 2 is minus 2. Okay, so polynomial which we'll get after multiplying this is x square minus x minus 2. Okay, now we have to check this polynomial, okay, over these values of x. Px equals to x square minus x minus 2 has either minus 1 or 2 as 0 or not. Means minus 1 and 2 are zeros of this polynomial or not. We have to check. Okay, now px at x equals to minus 1 is p1. It is very clear now. Value of polynomial at x equals to minus 1 will be p minus 1. Okay, so p minus 1 is, see, p minus 1 is equals to minus 1 square as it is x square minus 1 minus 2. So minus 1 square is plus 1 and this is also minus into minus 1, it is plus 1. So plus 1 and minus 2. Okay, so this is plus 1 is plus 2 and this is minus 2. So plus 2 and minus 2 will be cancelled out. So p1 is 0. Okay, means value of polynomial at x equals to minus 1 is 0. It means what? Since polynomial at x equals to minus 1 is 0. Okay, it is not I have cancelled. Okay, px at x equals to minus 1 is 0. Okay, that is, hence x is equals to minus 1 is 0 of the polynomial. Means at x equals to minus 1, this value of polynomial is becoming 0. It means what? This x equals to minus 1 will be the 0 of the polynomial. Now check at x equals to 2. Now px at x equals to 2 is p2. Okay, yes, then p2 will be, in place of x we will put 2. Okay, then this is p2 is equals to x square, which is 2 square minus x minus 2. So x square is 4 and this minus 2 is minus 4. Okay, so p2 is also 0. Since px at x equals to 2, value of polynomial at x equals to 2 is 0, that is p2 is 0. Hence x equals to 2 is also a 0 of the polynomial. Okay, x equals to 2 is also 0 of a polynomial and x equals to minus 1 is also 0 of a polynomial. Now see the seventh bit, px equals to 3x square minus 1. This is the polynomial, and at value of minus 1 upon root 3 and 2 upon root 3 we have to check whether this value of x and this value of x are zeros of the polynomial or not. So px is equals to 3x square minus 1. Okay, this is the polynomial. Now px at x equals to minus 1 upon root 3 is p minus 1 upon root 3. So p minus 1 upon root 3 is equals to 3 into minus 1 upon root 3 whole square. So minus 1 square is plus 1 and root 3 square is 3. Okay, so it will become 3 into plus 1 upon 3 minus 1. So this 3 and 3 will be cancelled out, and here it is plus 1 and minus 1. So value of polynomial is becoming 0 at x equals to minus 1 upon root 3. Since px at x equals to minus 1 upon root 3 is 0, that is p minus 1 upon root 3 is 0. Hence x equals to minus 1 upon root 3 is a 0 of a polynomial. Okay. Also we have to check px at x equals to 2 upon root 3. Okay. So value of polynomial px at x equals to 2 upon root 3 is p2 upon root 3. So p2 upon root 3 is equals to 3 into 2 upon root 3 whole square minus 1. Okay, after squaring it out, 2 square is 4 and root 3 square is 3. So 3 and 3 cancelled out, and remaining will be 4 minus 1. So 4 minus 1 is 3. So value of polynomial at x equals to 2 upon root 3 is 3, which is not equals to 0. Hence 2 upon root 3 is not a 0 of a polynomial. Okay. Now see next question, question number 4. Find the zeros of a polynomial in each of the following cases. Before starting this exercise, I have told you how to find 0 of the linear polynomial. See, x plus 5 is a linear polynomial, and 3x minus 2 is also a linear polynomial. To find the 0 of linear polynomial, we need to equate the polynomial with 0. So this is the polynomial. Then what we'll do, we'll equate it with 0. So px equals to 0 it is. So px is equals to x plus 5 equals to 0. Okay, so x plus 5 is equals to 0. We have to get the value, we have to get the 0 of polynomial, means such value of x at which this polynomial will become 0. So x equals to minus 5 will get. Okay, since x equals to minus 5 is the 0 of the polynomial. Why it is the 0 of the polynomial? Because if we'll put here x equals to minus 5, in this polynomial we'll put x equals to minus 5, then minus 5 plus 5. This polynomial is becoming 0 now. Okay, so x minus 5 is the 0 of the polynomial. Now not third bit, this is the fourth bit. So px equals to 3x minus 2. We have to find its 0 also. It's 0 again. How we'll find? We'll equate this polynomial to 0. Let px is 0. So px is equals to 3x minus 2 equals to 0. Then again 3x minus 2 is equals to 0. Okay. So after transposing this minus 2 to RHS, it is plus 2. So 3x is equals to 2 we will have. Okay. Now we have to get the value of x. Okay, so x is equals to 2 upon 3. So now this x equals to 2 upon 3 is the 0 of the polynomial. Why it is 0 of the polynomial? If you are putting x equals to 2 upon 3 in the place of x, you are putting 2 upon 3, then 3 upon 3 is cancelled out, remaining is plus 2 and minus 2. Plus 2 and minus 2 is 0. So polynomial will become again 0. Okay, so 0 of a polynomial is what? 0 of polynomial is such value of variable at which polynomial becomes 0. So that only we have to find in this question. Remaining 3-4 bits are left. Okay, so you solve that, equating the polynomial equal to 0. Okay, so in the next video we'll start with remainder theorem. Okay, what is remainder theorem and what is the use of it, and how to apply remainder theorem to solve a question. Okay, till then keep learning. Thank you.